11.3, finding domain graphically. You need to remember that domain is specifically talking about x values. And then we'll get to range in the next lesson, that's the y values. It says, what is the domain of the function shown in each graph below? So in Delta Math, it will have you choose from this drop-down menu what type of answer. I've already chosen that, so you can use that to help you if you need to look back at your notes, but your options are all values except for 1, all values except for 2, or some kind of interval. Just be aware that I've already chosen that. So on number 1, this is actually a reciprocal function. I don't know if it could be called rational as well, but my poster says reciprocal. And it's going to have asymptotes. Asymptotes are lines that the function comes close to but never actually touches. And so if I'm scanning my graph, every x value, so that would be actually vertically, so like this is the line x equals -10, there's a point, and there's a point, and there's a point. But right here, when x is 1, this line gets really close to it, but if I zoomed in, like on Desmos, you would see that it never will touch my dashed line. So I want to pick that this is all values except 1, and then kind of ignore all this. This is just x. This line means such that x. And then this is a notation for like in a set. Pretty much in the set of all real numbers except for, or x does not equal 1. So that's really all I look at, is x such that x does not equal 1. Is all I would need to know. Okay, number 2, kind of a funky looking graph. I see these hyperbolic curves again, and it looks like this end is going down and getting really close to this line, while this end goes up and gets really close to the same vertical line at x equals -6. I see it happening again here at 4, but everywhere else is good. There's going to be some kind of x value. So I would say x such that x cannot be two things. It cannot be -6, and it cannot be 4. And so remember in the last unit that those asymptotes come from having a denominator of 0 at those values. Okay, number 3 is like a square root function where it kind of has a stopping point here. But I want to look at the x values. I see that x is everywhere here. Right? All of this contains my graph. So how do I say that x's are only -2, -1, 0, 1 forever and ever and ever? Well, I would choose that it's an interval, and I would want to say x's are greater than -2. I should put or equal to, because there is a point here. Greater than or equal to because there's a point. If there were an open circle, you would not have or equal to. Because look at the number line. Every x value is going greater than or equal to -2. Number 4 goes away from itself. And so there's a piece here when numbers get bigger than 6, and then here when numbers get smaller than -2. So you would do interval again. You would put in x's are less than or equal to -2, or x's are greater than or equal to 6. You have to put or between them, I think. There's a little button to push. Number 5. My graph has all values here until looks like an asymptote. I can tell when a line starts to get almost a vertical, there's an asymptote here. And so I'm going to choose an interval again to represent it. All my x values are smaller than 2. I don't want to put or equal to because actually this graph will never touch at 2. It's just less than. And then the last one is similar to that. We've got 2 different curves. And we've got asymptotes here at 7 and here at -2. So I would say an interval, I would say x values are all less than or equal to, not even equal to, sorry, less than -2. It should never touch at -2. Or x's are greater than 7. That's it.